Ladies and gentlemen, welcome to Lab Stadium. Today, a very special episode of Iron Chemist for the spring quarter of 2008. Competitors will face a mystery experiment which will be revealed in a short time. But first, let me introduce you to the competitors. On my right, coming in, a childhood friend of mine, a great chemist and a dedicated student, I give you Samsung. And on my left, a rival of Samsung's since his early childhood, who's always lost to Samsung in every competition, but he's ambitious, he's studied, and he's ready to go. I give you Dim Sum! Without further ado, let us reveal the secret experiment. We have a past together, performed many times, with varying results. I want to see how a master chemist does it. Today's experiment is Ferrocene Chromatography! Competitors will be judged based on their speed and accuracy of completion. With that, let the battle of Lab Stadium begin.
First, I have to determine the order of the eluents through thin layer chromatography, where TLC plates, spotted with Ferrocene solution, are soaked in 5 different solvents: pure hexane, 2:1 hexane acetone, 3:1 hexane acetone, 4:1 hexane acetone, and pure acetone. To do the TLC test, you put a piece of filter paper into the beaker, you place the TLC plate with the Ferrocene solution dot on it into the solution, and you wait for the solvent to go up. A centimeter before the solvent reaches the top, you want to pull it out and mark where the solvent front stops. As soon as the solvent front nearly reaches the top, pull it out and mark where the solvent front is. Then, you can examine the plate to see where the orange dot is. The further up the plate the dot is, the more polar the solvent that you just put it in.
You're wasting my time. I already know how to do this. I know that the eluents must be used in order of increasing polarity, and therefore, the more acetone in the mixture, the more polar the eluent. So, while you are wasting your time doing your TLC, I will be preparing my chromatography column.
What's your order of eluents, Dim?
Well, the eluents goes hexane first, acetone last, and a smooth blend of 2:1 hexane to acetone in the middle.
Ha! I got the same results. Now to start with my secret silica column recipe. It consists of...
I know your recipe. It's a swab of cotton, which is to keep everything from running out the bottom. He's a feisty little fella. We'll stuff him in good. Next, I will grab a pinch of sand. Certainly the best sand I've seen in ages. Now, on to the main ingredient. Silica dust. Whoa, don't breathe this. It's 5 centimeters of lung cancer right here. Great. Now, I will get a dash of hexane. Smooth that silica out. Just gotta push it all through. Good. And to top it all off, some more sand. Okay. And now, for the secret ingredient, Ferrocene. Okay. And we just throw that right in there. And we're ready to begin.
What? But how could he have known to make his silica column that way? He's so dim.
Well, like it or not, Sam, it looks like Dim's done his homework, and now both of you have to eluate on equal playing field. You'll notice that both competitors are going to use hexane as their first eluent. The difference I see here is that Dim's technique is better than Sam's. He's labeled all of his compounds and all of his eluent beakers. Sam, on the other hand, has no labels, and he could easily get confused.
Oh no, I forgot which one's hexane, which one's acetone. I think this one's hexane.
Wrong choice, Sam. That's actually acetone. You want to use acetone last because that causes all the compounds to go through at the same time because it's the most polar. Uh-oh, it's supposed to be yellow, but it's coming out orange. When is he going to realize, Sam, you're doing it wrong, you need to start over?
Oh no, it's all coming out. I can't control it.
Oof, how embarrassing. Young chemists, let this be a lesson to you. Always label everything. Let's look over at Dim. And wow, look at that beautiful yellow color coming through. Looks like he's well on his way through his first elution.
Very, very good. Now, I will just push the rest of this yellow stuff through, and I'll be prepped for my second elution. Of course, before I actually start my second elution, I will rinse out any crap that's left in the pipette using some diethyl ether. This will definitely ensure the purity of my compounds.
Let's get a good camera angle on that silica column. Dim, show the camera your column. Looks like the white color is coming through. All the compound is being eluted appropriately. Make sure not to let the top of the column run dry. The sand layer and the ferrocene layer on top should never be exposed to the air.
Well, looks like all of it.
He's now going to begin his second elution using 2:1 hexane to acetone. You'll see a darker compound getting pushed through the column. As Dim does his second elution, let's take a break, and we'll be back when he finishes. Welcome back to Iron Chemist. At this point, Dim is just finishing his second elution. Let's take a closer look. The tricky part of this part of the lab is that you have to be very careful where the resolution changes. The orange color gets replaced by a darker red color, and that's when you begin your third elution.
Well, looks like I squeezed all the orange juice out of this pipette. Now, on to the third elution. Now I will be using acetone to make sure all of the compounds run through.
You'll know elution is complete when the column returns white. Let's check up on Sam. Looks like he's catching up.
Well, this solution's going a lot better. I have my eluents all labeled, and I'm getting a nice yellow color from my first elution. It's only a matter of time before all my mixtures are separated, but there's so little time.
So little time? You're right. It looks like Dim is finishing his last elution. Now all he has to do is put them on a hot plate, wait for all the solvents to evaporate, and then you're left with only the solutes. From the solutes, you determine the mass percent of the ferrocene compound.
It's drying time. Well, looks like I finally got you. It's just this one time. When I left, I was but the learner, but now I'm a master.
Only a master clumsiness, Dim. Look at your eluents.
Huh?
Look at your solutions.
What? No!
Let me explain what happened. Apparently, Dim left his beakers on the hot plate too long. What happens is that you want the hot plate to evaporate. You want the hot plate to evaporate all of the solvents.
It's all gone.
What you don't want is the solutes to sublime along with them.
Where did
You have
it
to
go?
be very careful to make sure that you leave them on heat just long enough so that the solvent evaporates and you're left with the pure solid. Here, Sam's technique is better. He's watching them very carefully.
Huh. All my solutions have dried. Now to weigh them. Yes, I have my mass percent.
Time is up. Well done, Sam. It looks like you just completed. Dim, where are your compounds?
It's all up in the atmosphere. I can't weigh this. What is this?
I don't think we can score you for that. I'm sorry, my friend, but the judges have made their decision. Sam Sung is today's iron chemist.
No!
I did it! I'm the man!
Nyee, your failure distracted me.
Well, like it or not, Dim, That's the way it goes. You should have paid more attention. Thank you for joining us today in this quarter's Iron Chemist. Farewell.